Hello students, today we are going to design RS flip-flop on multi-sim. We can design RS flip-flop on hardware and software also, but we are using software multi-sim to design RS flip-flop. As we know, RS flip-flop is known as reset set flip-flop or set reset flip-flop. There are two input R and S. R is known as reset input and set is known as S is known as set input. So we can design RS flip-flop using NOR gate and or NAND gate also. So firstly we are going to design RS flip-flop using NOR gate. So let us find NOR gate. From TTL logic family we are going to use NOR gate IC for which the number is 7402. So we are going to use two NOR gate for the design of RS flip-flop. So here is the first NOR gate, then second NOR gate, and for input we are going to use source. From digital source we are going to use interactive digital constant. So here are the two input. One is R and second one is S input. So for the output side we are going to use digital ground. So we are using digital ground to check the output, and to output side we are going to connect LED. So LED, from that we are going to use LED, green color LED we are using. So two LEDs are connected for the output, as there are two output in any flip-flop which are Q and Q bar. So let's connect now the input to the NOR gate, second input to the second NOR gate. So these are our two inputs R and S. So let us denote due to as R input, reset input. So this is our R input, and second input is our S input, set input. So it is our set input, and the output are denoted as Q and Q bar. So let's denote it as Q. The upper input is Q and the lower input is Q bar. So LED 2 will be replaced by Q bar. So this is our second output. Let's connect the output of first NOR gate to the Q and second NOR gate to Q bar. And second terminal of LED is connected to ground. Similarly, second terminal is connected to ground. So these are our two outputs, and as we know there is a feedback in flip-flop from the output side. So here is the feedback to upper NOR gate, and similarly for the lower NOR gate it is connected from Q output. So this is the design of RS flip-flop using NOR gate. Let us now simulate the RS flip-flop. So simulation is started, as there are both inputs are 0 initially. So we cannot apply both input as 0 initially. So let's stop the simulation, and firstly we will apply input either 1 and 0, either 1 and 0, R is equal to 1 or S is equal to 0, or similarly we can apply R is equal to 0 and S is equal to 1. So I am making S is equal to 1 and starting the simulation. So let's see what happens. So when R is equal to 0 and S is equal to 1, so set input is high. That's why our output flip-flop output is Q is high. As LED is on, output Q is equal to 1. So this is our first input condition in which when S is equal to 1 and R is equal to 0, our flip-flops output is set condition. Our flip-flops output is set condition. Let's apply both input 0. When both inputs are 0, R is equal to 0 and S is equal to 0, at that time there is no change in the output of the flip-flop from the previous condition. So whenever the both inputs are 0, R is equal to 0 and S is equal to 0, at that time there is no change in the state of the flip-flop. So this is second input condition. And in third input condition, R is equal to 1 and S is equal to 0. So as reset input is high, our output Q is in reset condition. So LED does not close. So this is our third input condition. When R is equal to 1 and S is equal to 0, at that time our output Q is in reset condition. How this happens? As in NOR gate, if any one input is 1, then output is 0. So as R input is applied to upper NOR gate, so output Q becomes 0 and this 0 again applies to the lower NOR gate. So both input in the lower NOR gate are 0, so output of lower NOR gate is 1. Similarly, in other condition, input condition, you can check this way of working of RS flip-flop. And last input condition, R is equal to 1 and S is equal to 1 is not permitted in RS flip-flop because in any flip-flop, both output Q and Q bar should be complement of each other. So we cannot apply R is equal to 1 and S is equal to 1 in RS flip-flop. So this is our simulation of NOR gate simulation of RS flip-flop using NOR gate. So these are four input conditions for which we get different output. So again we can rewind. If R is equal to 0 and S is equal to 1, we get the set output. Similarly, if we apply both input as 0, there is no change of the in the flip-flop output set from the previous state, and when R is equal to 1 and S is equal to 0, at that time output is in reset condition. So this is the design of RS flip-flop using NOR gate. Let's now design RS flip-flop using NAND gate. So design of RS flip-flop using NAND gate requires 4 NAND gate. So we have to design NAND we have to design RS flip-flop using NAND gate, for which we will use 4 NAND gate, and the output condition of RS flip-flop using NAND gate will remain same as in design using NOR gate. So we have to just check if we can design RS flip-flop using NAND gate also. So I am selecting the NAND gate from the TTL logic family, and the IC number for the NAND gate is 7400. So we are going to use 4 NAND gates. This is first one, this is second one, then third one, then fourth one. Now let's apply input from the source. So we are going to use digital source, interactive digital constant. So 2 digital inputs are required. So these are 2 digital input, and from power source we are going to use digital ground. So there are 2 grounds are required, or we can use only one ground and connect it to common ground condition. So this is second ground for the second output, and to check the output we are going to use LED from diodes. So from LED we are going to use green LED. So this is our LED for the first output and second LED for the second output. So these are components which are required to simulate the RS flip-flop design using NAND gate. Let's change the input notation. So this is U2 is our S input, Similarly, lower input is our reset input. So change it to the R input, and LED 1 is our Q output. So change it to Q, and second LED output is denoted as Q bar. So this is our Q bar output. Remember, in flip-flop, both Q and Q bar should be complemented of each other for any input condition. Let's now connect the input to the NAND gate. Similarly, second input to the lower NAND gate. And as we are applying only one input, we have to make common input for the two inputs of NAND gate, which is as input for the upper NAND gate, and for the lower NAND gate it is R input. So output of upper NAND gate is connected to the next NAND gate. Similarly, output of lower NAND gate is connected to the next NAND gate. And output of flip-flop is Q bar, Q and Q bar, which is connected to the LED. So this is output Q, and this is Q bar. As we know, in flip-flop there is a feedback from the output side. So we are connecting this output to this NAND gate. So Q bar is connected to upper NAND gate U1C, and similarly Q is connected to lower NAND gate U1B. So this is the design of RS flip-flop using NAND gate. Let's check the design by simulation. So firstly we are going to apply S is equal to 1 and R is equal to 0. Now let's start the simulation. As you can see, when S is equal to 1 and R is equal to 0, the output is in set condition. So this is our first input condition for which we get the set output as S is equal to 1 and R is equal to 0. Let's how we get the set output as S is applied into the U1A NAND gate, so we get the 0 here, and this 0 is applied to the U1C NAND gate, so any one input is 0 in U1C gate, so we get the output 1. So our output is 1, and similarly for the lower NAND gates U1B and U1D, the output of U1B is 1, so this one will be applied to the U1D, and second input is output Q, so which is 1, which is applied to the U1D, as both inputs are 1, so output of U1D NAND gate is 0. So LED does not close. So this is first input condition. The second input condition, so when S is equal to 0 and R is equal to 0, there is no change in the output condition of flip-flop. So this is no change condition for S is equal to 0 and R is equal to 0. Now let's apply third input condition, S is equal to 0 and R is equal to 1, for which we will get reset output means output is 0. So you have to remember, whenever the reset input is high and set input is low, the output will be in reset condition. So this is our third output condition. And lastly, when both inputs are 1, the both output Q and Q bar are same, which cannot happen because both should be complemented of each other in any flip-flop. So we cannot apply both input 1 in RS flip-flop. So you have to remember, when S is equal to 1 and R is equal to 1, this input condition is prohibited in RS flip-flop. So this is our design of RS flip-flop using NAND gate in multi-sim. If you have any question, you can ask me in the comment section of this YouTube video link. Thank you.